The reason for this type of pattern is because sometimes, if you think about, you are running three different machines, and when you plot each dot, you are combining the data points from three different machines, right? You have machine 1, 2, 3, each making the same product. When you are believing that each machine follows this type of distribution, however, in reality, it could be the machine number 1 look like this, the machine number 2 look like this, and machine number 3 will look like this, right? So compared to 2, 1 is small in terms of average, and compared with number 2, 3 is larger in average. So it's ended up, sometimes you're plotting the charts using the data from machine number 3, sometimes using number 1, number 2, and all processes, all machines will have different characteristics in terms of its output. So that could be one of the underlying reason for this type of data points, that it is hugging the control limit rather than hovering around the average. That's what you're seeing. So this is another pattern. We call it as a trends. You can imagine a situation where the machine can wear out over time, or the production or output is the function of time or season. For example, if you're plotting the number of customers visiting a ice cream store, a number of customers may be decreasing when the winter is approaching. So that is the underlying reason for this type of trends. So again, all these can give you some suspicion, or they give you the evidence for your suspicion, so that you can stop the line and go back and take a look at what is happening under the hood, and then you can decide whether to take an action or not. So that is the convenience and the beauty of control charts. So there are some rules we implement to detect the out of control processes. So these are the general patterns I have reviewed, and these are some specific rules where you can use to detect the out of control process. So this one is obvious. When you see one point outside of the control limit, that kind of gives you suspicion of what actually happened to the actual process average. So that is rule number 1. And rule number 2 is you see that 2 out of 3 is falling outside of these 2 standard deviation limit. That can be also used to give you enough reason to stop the line and do the investigation. Also, sometimes 4 out of 5 falling beyond 1 standard deviation, right? 4 out of 5 falling outside of the 1 standard deviation limit. That also give you reason to believe the process is out of control. This is also very interesting, hilarious. All of them, 9 or more consecutive points. 9 or more consecutive points falling to one side of the center line. Can you guess what actually happened to this process? Okay, I think you can guess what happened to this process. It's very likely the central line has actually increased to this point, right? So it is in fact a very rare chance. The probability of seeing all 9 falling above the average is actually very, very rare. If you think about the probability wise, it's 0.5 powered by 9. This will give you very, very little probability. Things like this can happen when the average is here. Things like this, all 9 of them falling beyond the average, is very small like this. Therefore, you have enough reason to think or be suspicious about the center line, whether it actually has shifted or not. Last rule, a run of 6 or more consecutive points steadily increasing or decreasing, right? So you see that 6 or more consecutive points steadily increasing. 1, maybe see 1, 3, 4, 5, 6, 7. So you see the consecutive increase here. That may give you another reason to think center line may have changed or something else have gone wrong in that process. So here's one thing I'd like to emphasize. The task of utilizing control chart does not actually end with identification of out of control point. Okay, that is actually beginning, right? When you have identified a process that is out of control, that is actually the beginning of your investigation. Okay, the difficult part is to link your theory on what may have gone wrong by looking at the chart and confirm it by looking up or referencing other facts or data, and then come out with corrective actions. That is actually something more difficult to do. So unfortunately, all we can do at this phase is by looking at the textbook data, and then we can only determine whether a certain process has gone out of control or not. So that's one thing we can do at this phase. It's still very useful.